Today in this video, let me do this problem which was left undone in my previous class. So let me do this first, then I will come to these two problems afterwards. Now what is given? See, I'll take this negation. See, here it is given negation of P intersection Q, this one, union negation of P intersection negation of Q. This is in a bracket. See, you should be very careful in writing the terms or the problem as such. Even if the parenthesis is missing or wrongly written, or intersection union wrongly written, you will not arrive at the answer at all. So we have to be very careful while writing the problem. So you see that this negation of the whole bracket union, this is P intersection Q, this is one. Now this is identically equal to, take this negation inside, so what will happen? Negation of P intersection Q, then this becomes conjunction, the negation of P conjunction negation of Q, keep this in a bracket, and disjunction means OR operation, disjunction, it is P conjunction Q. I use the De Morgan's law here in order to understand what is the meaning of De Morgan's law, because I will write it as De Morgan because it can also mean De Morgan's law. De Morgan's law is nothing but what is your De Morgan's law? Negation of P union Q, it is like this, negation of P disjunction Q is equal to negation of P conjunction negation Q, and for if it is conjunction, it will be disjunction here. So this is your De Morgan's law. Here I have used the De Morgan's law, the negation of this disjunction, this is conjunction, disjunction, therefore conjunction, and negation of this. Now you take this negation inside. So when you take this negation inside, again I am using only the De Morgan's law. So you will get negation of P is P, and this is again, it is conjunction means disjunction, it is negation Q. Then this conjunction is there. Take this negation inside. So negation of negation P is P, and this conjunction will become disjunction, and this will be Q. Keep this in a bracket, and this is disjunction P conjunction Q. Now you see that here this is P disjunction negation Q, P disjunction Q connected by the connective conjunction. So this I can use the distributive law, namely I will write this as P conjunction, see, P disjunction Q conjunction negation Q. Now you just check whether you have written it correctly, because if you are going to write it wrongly, then you will arrive at a wrong answer, or you will end up with a lot of confusion, so you will not arrive. So this is P. Now you see that P disjunction Q is here, conjunction is here, P disjunction negation Q. So we have got everything here. Now this will be equal to, see, P, this is P, and here what is the law that I have used? Distributive law. This I have used as what? Distributive law. Now you see that P, what is the value of this? I told you that it is Q conjunction negation Q is equal to F. This Q or P or whatever be the alphabet that you are using, it is a proposition. Q is a proposition. So Q, it can be P or Q for whatever be the value, whatever be the proposition there. This is the truth. That is Q. Arbitrarily anything is P conjunction negation P is equal to F, and P disjunction negation P is equal to true. So this is for all propositions. This is true. So okay. So therefore, what will happen to this? This is P union. This is, say, this is nothing but your complement law. So this is P. Then P conjunction disjunction F, and this is disjunction P conjunction Q. So this is, so in the place of Q conjunction negation Q, I have written as F. Now what will happen to this? So here I have used the law, namely the complement law, because we know that P negation P is equal to F. For any P, for any proposition, this is the truth. So you'll have this. Now P union F. What is P union F? See, you must know that P union F is equal to F. P intersection F is equal. See, this is the P. This is P. So you see that this is a dominant law. P intersection F is F. Okay. Now I use this P union F. What is that union? Empty. It is just like understanding empty set addition with another set. See, empty set is here, empty set, phi set, union A set will be equal to your A. So same way you see that here we are dealing with propositions. So here you see that P union F. So this is again your P, and this is, here I have used this law. See, what is the law that I have used here? I'll write it here. P union P intersection Q. So here what is the law that I have used here? I have used the law that P union F is equal to P for all P. This is true for all P. This is true. Now, so you have got P union P intersection Q. This is equal to P using absorption law. It is called a absorption. ABSO or absorption law. This is called your absorption law. Absorption law means here P union P intersection Q is equal to P, or it can be P intersection P union Q. In both the cases this will be true, and we have got the answer in this. So I insist on only one point, that while writing the problem you be very careful. This parentheses play a very important role, that if it is not written properly, then you will end up with a lot of confusion, or you will be beat about the bush to get the problem. So that is another difficulty, and that here this must be properly carried out. That means here the operations properly must be carried out, and wherever you must mention the laws that you algebraic here, propositional law, what is that you are using to arrive at this particular step. You see that, for example, here I have used De Morgan's law, here I have used De Morgan's law like that, here I have used distributive law, here what is the law that I have used here. Everything must be shown. Unless you show this, the examiner will not understand, will not take it for granted that you know the actually you are writing very blindly something in the paper. So you have to be very careful in writing this. So this is how this problem is done. So this problem is over. This problem is over. Now let us come to, I will give a small idea about what is called elementary sum and elementary product. Say by sum you just understand that your disjunction operation means you must take it as sum, and conjunction and operation, it will be your product. What I mean is that P, it is a disjunction, Q, this is a sum, whereas P conjunction Q, this is a product. This is a sum and this is a product, and I will call this as elementary. P itself is called an element. So suppose you have got two variables. What I mean is that if you have two variables like this, let P, Q be two variables, or here in this case two propositions. Write it here, propositions. propositions. Then you see that P itself is an elementary form, and Q and P union negation P and P then P like this, P intersection negation P. This is called your elementary product. This is elementary sum. This is elementary product. So this is called elementary product and elementary sum. Likewise, you can have all elementary product and sum. But if I am to specifically say, suppose you have got two variables, I write it as P union disjunction Q, P disjunction negation Q, then negation P disjunction Q, negation P disjunction negation Q. These are the only sum that you can write. This is called canonical form. Canonical sum. Canonical form, that is equal to canonical sum. This is your canonical form or canonical sum, you can call. So if there are two variables, then the number of canonical sum that you can write is only 4. Likewise, if you're going to write it for product, you see that it will be P intersection Q, P intersection negation Q, and negation of P intersection Q, negation of P intersection Q. So this is with regard to the product and this is with regard to the sum. So these are all called canonical product and this is called the canonical sum. But see, you see that you cannot while writing this, you cannot, this is not your K, P intersection K negation of P. This is not a canonical product. This is actually the value of this is equal to your F. So canonical, here in elementary form you can write. In elementary form you can write P union negation P, whereas in the canonical form you cannot write it as P union negation P, because P union negation of P is the truth. It is true. P union, this will be your true. But in elementary form you can write like this, but in canonical form you cannot write. So if your canonical form is where if there are two variables P and Q, then the number of canonical sum is or 4 and the number of canonical product are 4 and no more than that. And if you have 3 PQR, then you see that for sum there will be 8 canonical sum, and for product there will be 8 canonical product. Because of I will teach you as and when I proceed, but I will not separately write. I will just mention that if you have 3 variables PQR, then you see that the number of, yesterday in my previous video I told you that if there are 3 variables, if you are going to write the truth table, if you are going to draw the truth table, then the number of rows will be 2 to the power of 3, that is equal to 8. 8 rows will be there. In the 8 rows you will find that 4 canonical sum will come and 4 canonical products will come. Can you understand? So you see that if you are going to it is like this. See, it will be PQ. No, it will be if you are going to write the truth table, it will be P. It will be like this. See, I will write that also. See, for example, you write this. See, you have got this P. This is canonical sum I am writing. P, Q, R. Then the next is P, Q, negation R. P, union, negation Q, R. And P, union, negation Q, union, negation R. And another set will come for what? For the same sum, you will get what? Negation P, union Q, disjunction R. Negation P, disjunction Q, disjunction negation R. Negation P, disjunction negation Q, disjunction R. Negation P, disjunction negation Q, disjunction negation R. So you see that this is called your sum, canonical sum. Canonical sum. And if you replace this, this thing, the duality, if you write, duality means replace all this disjunction by conjunction. See, like this, conjunction, 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 conjunction. If you put the conjunction, it will become canonical product. So if you have three variables, the number of canonical product will be 8, the number of canonical sum will also be 8. Can you understand what I am telling you? So you see that these are the things that you must know. And what we are going to do now is that we are a compound proposition is given to you, and you are asked to obtain or try to express the given compound proposition into the we call it as, I will write here. See, what I mean is that, see, it is called a disjunctive normal form, conjunctive normal form. This is one set, and another set is principal conjunctive normal form, principal disjunctive form. This is PDNF, this is PCNF, this is simply DCNF, disjunctive DNF, this is CNF. So if you are given compound proposition, I told you what is a compound proposition. If you connect using this negation, disjunction and conjunction for the atomic variables or simple propositions, then you see that you will get the compound proposition. This is called your compound proposition. This is called your compound proposition because this is P is a atomic proposition, Q is an atomic proposition, P union Q is a compound proposition, and again this P intersection Q is a compound proposition. Again the whole thing I have used two-way implication, and this two-way implication has made it as a compound proposition. Still more complicating. Likewise, now what that we are asked to do is, you are given this particular compound proposition, you are asked to express or obtain means express. You use all the laws of propositional algebra. I have taught you propositional algebra. I have given you in the last video, and using the propositional algebra, that is algebra applied to propositions, using that, use all those and try to express this in the disjunctive normal form. Now what is the disjunctive normal form means? You are given a proposition, you express, that means what you try to express the given propositional, that is the compound proposition, into another form which is involving disjunction of the disjunction means union of disjunction of elementary products. See, what is that I have written here? Disjunctive normal form. What is the meaning of disjunctive normal form? Disjunctive normal form means disjunction of, this means what? Disjunction of elementary products. What is the meaning of that? Disjunctive normal form means given a proposition, compound proposition, express it as the union of or the disjunction of elementary product which conveys the same meaning as the given compound proposition. Are you able to understand? Now, how will you express this conjunctive normal form? Conjunctive normal form means given an expression like this, a compound proposition, you express it as intersection of or conjunction of elementary what? Elementary sum. So what is the difference that you find? So you see that when I say that it is disjunctive normal form means, disjunctive normal form means expressing the given compound proposition in terms of in the form of disjunction of the elementary products. If it is the conjunction of elementary sum, then it will be called as that is conjunctive normal form. Keep this in your mind. But you must know that when you are converting, the meaning of the compound proposition should not be changed. It can be expressed in a different way, but the meaning should remain the same. Okay? Now, coming to this. Now, let me make a difference here. Principal conjunctive normal form. What is the difference between these two? You find here it is a conjunctive normal form, here it is principal conjunctive normal form. The only difference that lies between these two expressions is that in this particular case it is conjunction of elementary sum, but in this case conjunction of the canonical, that is the conjunction of the maximum. In the sense, I will write that. See here, I have not mentioned that. Here I will write. See, this is, I'll write here. See this one, P union Q, P union negation Q, then negation P union Q, negation P union negation Q. These are all called min terms. This is called max terms. Max terms. And P intersection Q, P intersection negation Q, negation P intersection Q, negation P negation Q. This is called min terms. So you see that I mean P, even two variables are given. I write P union Q, P disjunction negation Q, negation P disjunction Q, negation P disjunction negation Q. These four will be called as the max terms. If it is disjunction, it is called max terms. And if it is negation P intersection Q, P conjunction negation Q, negation P conjunction Q, negation P negation Q, these four will be called as the min terms. That is the product. We call them as product of the variables. Here sum of the variables, and here the sum of the two variables will be written in this form, will be called as the max terms, and this will be called as the min terms. Keep this in your mind. Now let me come to the explanation of this principal conjunctive normal form. I told you that if it is simply conjunctive normal form, means given a compound proposition like this, express this as the conjunction of elementary sum. Come to this principal conjunctive normal form, means it is given a compound proposition like this, express it as same as this conjunctive principal. Here only the difference is principal. So here you write it as it is nothing but here again conjunction of, instead of elementary sum you must write that here it is max term. Max terms. The sum of the max terms. What are the max terms? If it is a product conjunction of the max terms. And likewise here it is a principal disjunctive normal form, means it is the conjunction, the disjunction of, here it is max terms, means it is min. Canonical terms, canonical form. These are all called canonical forms. Canonical forms of the sum of the variables, and here it is called the product of the variables, and this is called min terms. Okay, therefore I will repeat this again. So you see that by elementary terms we mean P is an elementary term, P union negation P is an elementary sum, P intersection negation P is a elementary product. Like that you can get the elementary terms, elementary products and elementary sums. But if I say specifically that here there are two variables and P union Q, P, there are, see, more than this you cannot write anything other than this. If you are going to write P union negation P, it is equal to your T. So you cannot write this. These are the 4 and only 4 max terms, and these are the 4 and only 4 min terms. Likewise, if you are having P, Q, R as 3 variables, 8 not more than 8 max terms and not more than 8 min terms are available. Okay, you can write. Okay, now, so what is now disjunctive normal form? Means given a compound proposition, express it as, here disjunction means what? Disjunction of what? Elementary products. See, here it means conjunction of normal form. Conjunctive normal form means the conjunction of elementary sum. Coming to this principal conjunctive normal forms, this principle makes a difference. It tells you that it is nothing but, again, conjunctive means conjunction of, it is here elementary sum means he is max terms. He must have only sum of the max terms. You can write this sum of max terms. See here, sum of max terms. And here it is what? Here it is min means it is disjunction. Principal disjunction means sum of min terms. So this is that. And remember only that if you are given a compound proposition, you are going to convert it into what? If it is principal disjunctive normal form means disjunction of conjunctive sum of the min terms. If it is, see, it is like this. Principal conjunctive normal form means the conjunction of sum of max terms, and if it is principal disjunctive normal form means the disjunction of sum of min terms. The only thing that you must remember is that if you are going to express it in a different way, then the meaning of the original that is this compound proposition conveyed should not be changed. That means the meaning of the compound proposition and that which has been expressed in a different form should convey the same meaning. Otherwise you are wrong. Can you understand? So this is, so given this thing, a compound proposition, writing the equivalent in this form will be called as a disjunctive normal form or conjunctive normal form, principal in the conjunctive and principal in disjunctive, as the case may be here. Okay, now with this small ideas on this, let me come to this particular problem. See, now remember those, see, then only you can write. See, we will write this. I will do this. Let me go fast. See, this is, see, what is that you are having? Negation of P union Q, and it is if and if only P intersection Q. Now, what is it identically equal to? It can be written as, see, the meaning of this is P two-way implication. Two-way implication means what is the meaning of this? P implies Q and Q implies P. So this means that negation of P union negation of Q intersection negation of Q union P. So this is the meaning of that. See, here it is, P implies Q means what? P implies Q means P implies Q. Here I'm sorry. P implies Q. What is the meaning of P implies Q? P two-way implication means it is P implies Q and Q implies P. What is the meaning of this? Negation of P union Q intersection negation of Q union P. So this is, so keeping this in my mind, I write this as negation of P union Q. This implies P intersection Q, and what is it? I'll rub this now. See, this is what I'll write here. So this is P intersection Q implies negation of P in Q. So this is what I'll have. So negation of this implies this, and this in turn implies this. Now I'll write this as, straight away I'll write this as P here disjunction Q, and this one is union P conjunction Q. And here I will write this as, it is negation of P disjunction conjunction Q union negation of P union Q. this. See here, what is that law that I use? I use this this one, that is P implies Q is negation of P union Q. I use the equivalent. What is the equivalent of P implies Q? Negation of P. See here, I have written here negation of P implies union Q is P in Q. Union, this one, P intersection Q. Conjunction, negation of this, union, negation of this. That is what is given. Now this will be equal to, now take this is nothing but you rewrite as it is P conjunction, disjunction Q, disjunction P conjunction Q, keep this like this, and it is conjunction, take this the negation inside, use the De Morgan's law, so it is negation of P, disjunction, negation of Q, keep this another bracket, take then here is disjunction, take this inside, negation P, disjunction, conjunction, because it is De Morgan's law. De Morgan's law. I use the De Morgan's law. Now what is wanted here? Get the disjunctive normal form. What is the meaning of disjunctive normal form? Disjunction of elementary product. What is that? Disjunction of elementary product. Elementary product means what? Even you can have P intersection P, Q intersection Q. You need not write as a Q intersection Q as, so Q intersection negation Q or P intersection negation P. You can write, because even though it may mean P intersection negation P is equal to F, you can simply write that because it is an elementary product. Okay, elementary sum means P the disjunction negation P, you can write. So you see that, keep that in your memory. Now what will happen here is that now I must write this as disjunction union of the elementary products. So I will write like this. So what does it mean? I must always remember to have this. What is that? Union must come. See, this must come, this must be maintained, and this conjunction must be, somehow it must be removed, and you must have elementary product. See, this is an elementary product, this is an elementary product, and here you must connect them by this disjunction. So it is an art of doing, or it requires some experience, something like that. You practice a lot, you will get. Otherwise, that is, just think it over, you will get. There is every chance that you may go wrong, you may commit a mistake, but see that you meticulously or very carefully deal the problem, that you will not commit mistakes. Okay, now, so I'll write this as P conjunction Q union P union Q. So this is, I use the commutative law. Here I use the commutative law, and I can put like this. Here again it is that you can write this as negation P union negation Q, and this is union, I'll just remove this, union negation P conjunction negation Q. I'll write here. Now I have got here, see, this is an elementary product I have got here. Here also there is some elementary product I have got here, and they are connected by this disjunction. I must concentrate only on this part to see that I get it as disjunction of elementary products. So what I do here is that it is P conjunction Q, then disjunction, take this P inside, that is, use the distributive law. Here what is that I have done here? Commutative law. Here I used, that is commutative law I have used. Now you see that you take this inside, P conjunction, see, P conjunction negation of P union negation of Q. Okay, see, P conjunction of this disjunction, then Q, then it is conjunction, then inside the bracket negation P disjunction negation Q, and these two I have written here, and you are left with union negation P intersection negation Q. So what is that I have taken? I have taken this P conjunction of this union Q. I have used here distributive law. I have used here the distributive law. So what is that I get here now? Now you give me this. So don't disturb this because let it be as it is. So this is your elementary sum. Even P intersection Q is an elementary sum, elementary product. And then you have got like this. Take this inside. So when you are going to take this inside, P intersection negation Q, P conjunction negation Q, then I will mark like this. P conjunction, see P I will put here. P conjunction negation P union P conjunction negation Q. So use distributive law. Here also I will use only distributive law. P conjunction negation P disjunction P conjunction negation Q. Then similarly you do this Q conjunction negation P, then conjunction, see disjunction Q conjunction negation P, disjunction, here you have got here disjunction, Q conjunction negation Q, and finally you have got what is that? Here I will see this UV is here, here it is, I will write it here, I will write it here. So you see that this I am using what is called my distributive law. So what is that I have done here is that here I am retaining this P conjunction Q like this, disjunction, use distributive law, P conjunction negation P, disjunction P conjunction negation Q I have written here. Likewise, you have to keep this in the bracket, there is every chance that you may go wrong like this, okay. Then Q conjunction negation P, then disjunction Q conjunction, here it is negation Q. See Q negation P, negation Q. Then the last term is negation P conjunction. Now you see that this is a elementary product. This is an 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 elementary product. This is also an elementary product. They are connected by this what disjunction. So you see that they are connected by this disjunction. Therefore, this is the equivalent of this expressed in disjunctive normal form. So this is your DNF, disjunctive normal form. Are you able to understand? So what is that you have to do here is that do all manipulations known, use the laws of algebra, that is propositional algebra. Here the laws of algebra apply it to propositions. Use those ideas and De Morgan's law, distributive law, commutative law, associative law, and all these things you apply here and then arrive at this particular this thing. Now you don't write anything P intersection negation P as your F. Don't write that. Don't write that. So you keep it as it is. Then only it will be called as an elementary form. So this is expressing the given compound proposition as a what? The disjunction of. This is disjunction of elementary products. And this is called your disjunctive normal form. And I will do, if required, there may be a chance that in the coming videos I will be doing a problem on what? CNF, that is conjunctive normal form also. But this is a problem specifically I have taken here. Therefore, this is done. Now let us come to the third problem. See, third problem, as I told you here, what is that? Here you have got, let me come to the third problem. Here you have given that S is, what is your S given here? It is negation of P implies R, and it is Q two-way implication of P. Now what is that you are asked to find? PCNF. You are asked to find PC. What is the meaning of PCNF? Principal, conjunctive, normal form. What is, see, leave alone this P. What is conjunctive normal form? Expressing the given compound proposition in terms of the conjunction of elementary sum, but with the same meaning maintained. That is, the meaning of the original compound proposition is not changed. That you have to remember. Now, coming to this principle, you have to write, be careful with the spelling, principle, CNF. What is the meaning of this? Here again, it is the conjunction of, what is that? If it is conjunction, you write this as max terms. Conjunction, sum of max terms. Conjunction of, that means conjunction of sum of the conjunction of max terms. You right. That is conjunction of your, yes. Even this is not required. Conjunction of max terms. What is the meaning of max terms? Here you have got only 3 PQR. You can find that PQR. 3 variables are there. Therefore, if you are going to write the max terms, how many max terms will be there? 8 max terms will be here. It will be, 8 max terms will be P disjunction Q disjunction R, then P disjunction Q disjunction negation of R, P disjunction negation Q of disjunction R. Like that you will have 8 terms like that, 8 max terms. Are you able to remember? Can you follow what I am telling you? So you see that, so remember this, keeping this in your mind, you must be able to convert this to principal, say it is principal conjunctive normal form. How that is done, I will tell you. See, so this is, now apply all the algebraic laws applied to propositions here, then you will get. Now what is this? This is nothing but, see, this is equivalent to, now this is of the form P implies Q. P implies Q equivalent is negation of P R. Are you able to understand what I am writing here? So it is P implies R means negation of P union R. But here in the place of negation P you have got, so negation of P, this one, and I will write here, this is nothing but your Q implies P intersection P implies Q. This is the idea of a two-way implication, and if and if only condition applied to P and Q, therefore this is the meaning of that. So what is that I have written here? So here I have used equivalent, EQIVALE, equivalent of P implies Q is equal to negation of P union Q. And here I have used the equivalent. What is the equivalent of this? This is the equivalent of this. Then you change this. What is negation of P? It is P. Then it is disjunction of R, and here it is conjunction. What is this? Negation of Q, disjunction P, and it is conjunction, negation of P, conjunction, it is disjunction QR. Now this is what we are having. Now you see that I am writing the equal negation of P is this, negation of this, and conjunction means this, and conjunction. Here you see that negation of P, here it is negation of Q, disjunction P, negation of P, disjunction. Now this is what we are having. Now see, almost we have got, see what is this? This is conjunction, this is conjunction. What are the terms inside? They are all sum. Sum means union means disjunction of elements. Disjunction of the variables will be called as a max term. So disjunction of the variables, so this is a max term, this is a max term, this is a max term, but they are all incomplete max terms, in the sense that every max term or a min term should have all the three variables, because you are having three variables here, P, Q, R. So every max term and every min term should have all the three variables there. Now you see that though these are max terms in its own right in its own sense. They are not the actual max terms, because you see that Q is missing here, here R is missing, and here also R is missing. Now we have to manipulate the situation or write it in a different form so that this R also comes, but without changing the meaning of the what? The compound proposition. For example, I will tell you that this half is there. Do not change the value of this. You multiply this by 10 and divide it by 10. You see that it remains the same. Okay. So likewise, you can do some manipulations, but that manipulation or something, what operations that you give should not change the meaning, actual meaning of the proposition, that is a compound proposition. It should not result in changing the meaning of the compound proposition. So bear that in your mind. Now we will write. How to write this? See, this is, so here I am able to get, what is this? This is principal conjunctive normal means conjunctive. Conjunctive means intersection. Conjunctive normal form means you must have max terms. So I am having max terms, but the max terms are incomplete in their own rights. So I am going to change it to become a full, giving the full meaning, which involves all the three variables. So what I do here is that P disjunction R, then I want this, I add this disjunction, and I want, which is missing here, Q, I write it as Q conjunction negation Q. Now you read this, Q conjunction negation Q. What is Q conjunction negation Q? For whatever be the value of this is your F, and F union P is equal to P for all P. This is true. So you must know, I am bringing in two ideas here. One is the Q, I am introducing certain thing here which is not affecting the meaning of this term. It is not affecting the max meaning of the max term. It is P union P disjunction R remains the same. But I add what is missing the Q. I add that. How do I add? I add it in a sense that it is give the term becomes F. It is a that is it becomes F. What I mean is that you add Q intersection F, this thing, then it becomes what? False. This is false. This is false. No, false union anything is itself. So I add this. I add with this an empty, that is a 0. It is just like a 0. This plus 0. It is just like 0 only. So I do this here. Now same way you apply here. So what is that you will do? Put a line, this thing like this. So negation Q, you can disjunction P. Now what is that you will do? Do the same thing. What is missing here? It is R conjunction negation R. Now the meaning is not changed. Then again this, here it is negation P union Q union, then R intersection negation R. This is what you have. Are you able to understand? So here I have added something which is just like you are adding 0 to a number. Here 0 to a number, 0 to, so addition of a 0. So it is not going to change the meaning of the compound proposition in any way. So this is what I am having. Now what I will do here is, I will do, see, yes. Now you apply the, so you apply, so remember that here something is missing. Missing should be added in such a way that the meaning is not changed, or the meaning of the statement is not altered. This is just like your 0. This is just like your empty set. This is just like your empty set or 0 in whatever way you call this. So this sentence has no meaning. It's a 0 meaning. The proposition is a 0 meaning. That's all. So this is, now you apply the distributive law. How will you apply this distributive law? P, say I'll write here, P disjunction R disjunction Q. Then you see that this is it is connected by this conjunction. So conjunction, I'll put it very bigger. P disjunction R disjunction negation of Q. So you see that this can be split into sum of product of two max terms, P union R union Q. then P union R union negation Q. And likewise, put like this, expand this also, negation of Q, disjunction P, disjunction R. Then again you see that I am writing here. Here you see that I am writing here. So I'll write it in the, see next here. See here, I'll write it here. So what is that will have? Negation of Q, disjunction P, disjunction negation of R. Then see you are left with here what? Negation of P, disjunction Q, disjunction R. Then it is negation of P, disjunction Q, disjunction negation of R. So what is that I have done here? I have used the distributive law. What is that I have used here? I have used my distributive law. So what is the distributive law here? P union R union Q. Disjunction, conjunction here I have put it in a very big, it's something very shown very distinctly here. Very distinct here it is. So it is conjunction of P union R union negation Q. Likewise I have written for this Q, negation Q, disjunction P, disjunction R, then negation Q, disjunction P, disjunction negation of R. The next one is negation P, negation Q, disjunction R. Then it is conjunction, put it as I told you, just make it very distinct here. So this is what we are having. So I have given the distributive law to write this. Now I'll rewrite this. Say what is that? Always write it in the form of what? P, Q, R. Okay, then put it like this. Then P, negation Q, R. Okay, then this is P, negation Q, negation R. Then it is here I am writing. Here it is, see I have written here 1, 2, 3. Then it is P, negation Q, negation R. Then it is, see I have written here this negation, see P, negation Q, negation R. Here this is negation P, Q, R. Then it is negation P, Q. All we have to be very careful. I repeat this. See what I have done here is that I am rewriting this. P, Q, R. P, negation Q, R. Then this is P, negation Q, R. Again, P, negation Q, R. Then conjunction of P, negation Q, negation R. Then conjunction of negation P, Q, R. Negation P, Q, R. All conjunction, disjunction. Inside everything is disjunction and these are all conjunction. And conjunction, negation P, Q, negation R. See, negation P, Q, negation R. Negation P, Q, negation R. So I have written here. So what is that I have got here? Now you can write this. See, P, Q, R, only one is existing here. But P, negation Q, R, P, negation Q, R, these two are the same. Repetition of terms should not be there. Then you see that P, this is only one is there. And here again there is only one. Here with regard to P, you should have 4. With regard to, see, when you write the max terms, when you start with P, there will be 4 terms. When you start with negation P, 4 terms. Therefore, there will be totally 8 numbers of max terms and 8 numbers of min terms. Here you see that, here I have got here this P1. This is nothing but 2, both mean the same, so don't worry about that. 1, 2, 3. So you have got 3 terms starting with P has come and 2 terms starting with negation P has come. Know that. Here what I will do here is, what answer you will get here is now. So what is your yes now? So I'll write here yes. So yes is P, Q, R, intersection. Now these two can be combined. See, it is just like, let us suppose that it is your capital P intersection capital B, but capital B intersection capital B is P, because idempotent law. Here it is what? P intersection P. P intersection P is P. It is an idempotent law. P union P is P. It is called an idempotent law. So these two can be combined and you can write this as P union negation Q union R. So this is one. So this one. Then conjunction P negation, this one negation Q negation R. Then conjunction negation P union Q union R. Then negation P union Q negation R. So these are the things that you have got. So here you see that I have combined this using the law, that idempotent law, P intersection P is equal to P. Using that idea, I am getting P union Q union R, P union negation Q R, and P union negation Q union negation R, and the other terms are negation P. Starting with P, you have got 3 terms here. Negation P union Q union R, negation P union Q negation R. So this is your, now you see that this is your principal conjunctive normal form. Why this is called as principal conjunctive normal form? Because conjunctive means all this intersection. See, this is intersection, this is conjunction, this is conjunction, this is again, this is conjunction, this is conjunction. So conjunction of max term, this is a 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 max term. So conjunction of the max terms. See, it is a conjunction of the max terms will be called as the principal conjunctive normal form. Why we call it as principal conjunctive normal form? Because these are all canonical form. That means they are in the canonical form. The canonical form means forms of this type, and it is, since it is the conjunction of the max terms are nothing but the canonical sum, it is called the principal conjunctive normal form. Now let me complete with the next part. That means you are asked to find. So this is what we are having to find. To find principal disjunctive normal form. What is that you are asked to find? Find the principal disjunctive. You have found PCNF. Now I am going to find the PDNF. See the method. See, method is method. See, first step 1. Step 1 is you find the negation of yes, which is nothing but write the PCNF with missing terms. Then negation. Now step number 2, negation of negation is apply De Morgan's law to 1. So what is that I am going to do now? So what I will do here is that the first step, if you are going to have found, see if it is PDF, see the other way about. If it is PDNF, if you are going to find the PCNF, same principle. So you have found in this particular problem, you have found PCNF. Now you are going to find the PDNF, for which the procedure is you find the negation of S. Negation of S means now you are going to write negation of S as the new PC. Again it is going to be a PCNF, but with the missing terms. Missing term means what is that? Here I told you that if there are P, Q, R or there, then the number of max terms should be 8, number of min terms should be 8. Now here you have got your 1, 2, 3, 4, 5. So 5 terms are there. 3 terms are missing, so you have to write the 3 terms. Are you able to understand? If it is going to means again the same principle. If it is max or min, both may if you are going to find negation of S means you have to apply the same principle here. So you see that when you are going to write negation of S, you write the PC, again PCNF with the what missing terms. Now what is missing here? You see that PQR, P negation QR, then P negation here. So what is missing here? P. Starting with P, only one term is missing. Only one term. It is PQR, P negation QR, and you must have here, you see that P negation. So the missing term is P. It is Q, see P. So this is the missing term. So P disjunction Q, disjunction R. The next must be P disjunction Q, disjunction negation R. But that is not coming, so I am writing that here. Then again it is a conjunction. Come to this. Here what is that you are having here? Here you see that. It is negation P Q R. It has come. Very good. Negation P Q R. Here what is missing here? Negation P Q R. You must have negation P Q, negation R. See here, negation P, the disjunction Q, the disjunction R has come. So what is missing here? Negation P, disjunction, negation Q, disjunction R. So this is missing. Negation P, disjunction Q, negation of Q, R. And another one is, then it is again disjunction, conjunction of negation P, what is that? Negation P, it is disjunction, negation Q, disjunction, negation R. See, these are the missing terms. Say negation P, Q, R has come, negation P, Q, negation R has come. So you must write with negation P, negation Q, R here. Then negation P, negation Q and negation R I have written here. So here there are 2 terms missing, I have written here. Here there is only one term missing, I have written that one term, and everything, these are all max terms again, and they are joined by the conjunction. Now this is again a PCNF. This is again a PCNF. Now I will apply this negation. Now what is the step 1 I have carried out? What is the step 2? Negation of S is equal to or equal to. Now what is the meaning of what I have written here? Apply De Morgan's law to 1. So when you apply this De Morgan's law here. Negation of P union Q union negation of R. This one, negation P, negation Q, R. Negation P, negation Q, negation R. Now, I will not go deep into this. So you see that when you take this negation inside, it will be negation P. This disjunction will become conjunction. So it is negation Q. Then again this conjunction. Negation of negation is R. This is minor. And this will become as what? Disjunction, it will become conjunction, it will become disjunction. Then negation of P is P. Negation of Q is R. Again it is, so negation of Q is Q. Then again it is conjunction. It is negation of R. Then this is disjunction, the conjunction, so it is disjunction. Then negation of P is P. Then it is conjunction. Negation of Q is Q. Then again it is conjunction. Then negation of R is R. So this is okay. So what is that I have written here? I have taken this negation outside, inside negation P. This will become conjunction. This will become conjunction. This is negation Q. This is negation R. Negation of R is R. Then this conjunction will become disjunction, and this is negation of P is P. Then it is conjunction. Negation of Q is Q, and this is conjunction. Negation of is R. Then again it is what? A conjunction. It is becomes disjunction. Apply here. It is P here. Then this will become conjunction. This will become conjunction. Negation Q is Q, and negation of R. So what is that you are having? This is, can you see this here? See, union of, disjunction of, these are all min terms. These are all min terms. Min terms means what? Products. They are called products. That is, you take the conjunction of the variables. If you take the conjunction of the variables, they will be called as the product. They will be called as the min terms. You can find this. All these are all min terms connected by what? The disjunction. And for this is nothing but what? Principle. Now you tell me this principle. It is, you have used disjunction. So disjunctive, normal. Why it is called a normal form? Because every term here, they are canonical terms. Canonical, it is a canonical sum. So it is nothing but canonical products or min terms. So it is disjunction of the canonical products. Therefore this is called a principal disjunctive. What we arrived at was principal conjunctive normal form. This is the method of doing it. You have to be very careful in applying the algebra of algebra of propositions, and you have to know the methodology of doing it, and simplification you must know, and you must finally see that if you are going to express it in a different form, the meaning of the original compound proposition should not be altered. So this is thing. So we will see more problems in the coming days in my videos. Thank you.